Okay, hello everyone. Today is day 6 of coding every day to prepare for full time. Now, I'm not gonna lie, I'm already a little burnt out, but we gotta do what we gotta do. So, let's see, oops. That? No? No! Let's do that. Okay, sorry. Gotta get to the back of the tree. Alright. Last time we were looking at daily temperature, and I was like tired while going through it, and I am a little tired right now. I'm also really hungry right now, so it's probably not gonna work very well in my favor. But we're gonna do what we gotta do. So let's go ahead and let's pull that up. Alright, actually, do you not remember how this problem went? Even though I literally was just doing it yesterday. Okay. So. Given in array of integers called temperatures, which represents the daily temperatures, we need to return an array called answer, such that the answer of I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, then it would be 0. Last time we tried to do some solution where we kind of just do a greedy approach, but that's not necessarily going to work. I'm wondering now if we should do similar to. What problem was it? It was similar to min stack. Okay. Is there a time constraint on this? If the temperature says 70 day, then the future warm temperature must be either. We could remember when all of them occur next. We could remember when all of them. See, when you use them, it's just like you're not being accurate. Then what? Supposedly, I should use a stack to solve this. So, one of my first thoughts is let's draw it out actually. So one of my first thoughts is how would I say Shimonokwe. You do like So like, let's say we get like 71, okay? Or let's say, okay, we have, let's just copy that. Whoops, too big. Let's do like big, but not that big. Okay. Okay, so we'll do 73. Put in the stack. Okay. And then we'll put like a maybe like a counter right next to it. So we go 74, bigger than this, pop it out. So we pop out the 73, and then we had 1 on it, so we put the 1 there. Okay, so then we put 74 in here. Okay, and 1. And we have 75. Okay, so 75 is bigger. So we're going to pop out the 74, put the 1 in there. And now we're going to put 75 in here, and the 1. Okay. Then I'm going to put 71 in here. 71. And I think I'm going to do like a swapping technique. So like I want to constantly see. Oof, no, because like then it could be like 73. Ah. Damn. I'm gonna continue with this. I have a semblance of an idea, but it's not gonna run pretty. I'm gonna put 69 here. Okay. Okay, now I put 72. And then we're gonna just keep popping until we hit something bigger. So we pop the pop a 69. So we say 1 here. Then we pop the 71. So we have 1, 2. Right? So we put those there. So this is still like empty, but we'll put 2, 1. Okay, so that's after the 72. I'm gonna put the 72 in here. Okay, now we get 76. So now we pop. So we get rid of the 76. We pop the 72. It's just 1, and the 75 is gonna be 4 now. And gonna have to move these. Okay. So the placement of the numbers is gonna be a little interesting because those kind of go all over the place. So now I have 76 in here. 1. Let me put 73. 1. That's 2, and then we hit end of it, end of file. So then these get evaluated to 0. And then we just push those here. Okay. So low-key, I'm thinking when we push the index, instead of the number, we'll push the index. That way we can relate to what day it is. So we'll push the index. Somehow I'm going to have to propagate downwards to basically increase each thing. So eating these freeze-dried Skittle candies. I'm so not vibing with them. Not really enjoying them. But I'm kind of hungry, so I'm working on them. I need to go like make real food soon. So I'm gonna say that the answer rate is gonna be this times the length of temperatures. If I remember correctly, this properly creates it, yeah? Yeah, it does. Dope. That's what I wanted. Okay, initialize, I'm going to say the stack equals that. I'm going to say for index in range of 0 to the length of temperatures, print temperature. You know, I don't. Okay. Print temperatures of index, and then make sure it's not out of range. I usually don't do this like range thing. Whoops. All right, dope. It's nice. Okay, so I'm going to push it to the stack. I'm going to say stack.append. I'm going to say new element equals index, and then we're going to say 1 for number of days, and we want to append that new element, but first I must do a corrective measure to increment each item. So I'm going to do while stack is while length of stack is greater than 0, I'm then going to basically do like a pop situation. So I'm going to say top equals say temp stack equals 0 times length of stack. The top will equal stack -1. I'm going to say the top of 1 plus equals 1. This is kind of slow time complexity. I'm basically popping every single item and then readjusting their values, incrementing it by 1. Then I'm going to then decrease. So I'm going to say stack equals stack without the last value, and then at the very end, oh wait. I'm going to say Python append to front. Come on. Insert. Nice. Wait, I'm tripping. Okay, but what's the real 0? Man. Oh. Yeah, peak. Let's go. Yep. This is a full thing, and then I'm basically going to just say stack equals temp stack. So, we now do our increments. What's up, big guy? Thanks, chill out. Okay, so this increases everything. Now I'm going to do while temperature of index is greater than I want to make sure it's not empty as well. While length of stack is greater than 0, and the temperature of the top value, the most current value, is greater than the temperature of the previous stack. Okay. Then I want to pop it and correct the answer value. So I'll say answer of my cat's tweaking right now. Holy heck. Okay, that does that. Yep, so now I'm updating the answer, and then I'm going to pop it off, saying it does not exist anymore. So stack is now going to equal stack popped. Okay, so that pops that. And after all that popping, now I'm going to say that stack dot append new element. Element. Oh, my nays. Can't type. My cat is tweaking right now. Buddy, relax. I think I'm missing something here. I'm gonna run just to see some coloring. Yeah. Well, that's one for sure. Misspelling. Ooh, infinite time? No, okay. Not infinite time, but I'm like increasing too much. Did I just put 0 in here? Like, oh, yeah, that makes sense. It should be 1. Probably runs like a speed error, right? I mean, by judging how like slow this is running, I'm definitely gonna probably have the time limit exceeded. Yeah. Whew. Christ almighty. Yeah, definitely a speed error. I'm guessing it is because of this. For sure. This is not the problem. This is fine. I have to do this. This is the problem. I'm wondering if there's a smarter design I can do. Okay, like I put 73 in here, and then I put 74, and now this is 1, and it's done. Okay, now I put 75, and this is 1, and it's done. Okay, now I put 71, and then this is 1. Okay. And then I put 69, and then this is 1. Okay, then I put 72, and then this is 1. And then maybe I can do like a carryover thing. So 72 is going to cancel out 69. And then 72 is also going to cancel out 71, so we're going to carry that 1 over to make it 2. And then so these get canceled out. And then now 72 is going to check this. This one's going to be fine, so we're going to drop the 3 down here. So I'm going to remake this stack. So now we have 72 and then 75 with 3. Now I'm going to add 76. This is 1. I'm going to cancel that out. And then on 75, I'm going to check it. I'm going to drop this 1. This is 4, so I'm going to cancel that out. Then make a new one because I'm writing like crazy over here. I'm going to put the 76 here. Put the 73, and this is 1, and then have nothing else, so then this gets cleared out. Potentially, I think if there's no like edge cases, I think that might work. The drop down method. Dude, relax. Okay, so I'm gonna get rid of this. I'm gonna call this additive value. I'm gonna put it as 1 starting off because it's always gonna be 1 for a day. Now, going through this, I'm going to say new temp additive is basically going to equal the current additive wait, hold up. I could totally fumble this. Oh, let me redo this again real quick so I can understand like the algorithmic integrity of this. So we have 73, nothing. 74, drop down, add the 1, then we pop it. Then we do the 75, drop down, add the 1, then we pop it. Then we have the 71, drop down, add the 1. Can't do nothing about that. It's pretty much furthest we go. Then we do 69, drop down, add the 1. And we do 72, drop down, add the 1, and then we can pop this. 1 carries over here. Pop this. 2 carries over here. Can't pop it. Okay, that should be fine. I think that's fine. So I'm going to say equals additive value plus the top value currently, which is going to be, oops. So the additive value is like number of days. I guess probably should be more discrete on that, but you know. So we're gonna do that, and then before I do any popping, I'm going to say, whoops, I'm going to say what's up, man? I don't even need this temp additive. I can probably just, whoops. Does that run? Oh, this is so hurting my brain. Oh, let me just do a little quick run just to see. Okay. Incorrect. But these two passed, oddly enough. So I got all ones here. Oh, I'm not throwing the additive value in. Runtime error. Oh, because there's nothing there. Of course, I have to check it. Sorry about that. You know, if something exists, now we're gonna clean that up. Still nothing. Ugh! Why? Okay, hold up. I need to run through my algorithm to see like what exactly is like what exactly is getting cooked right now. Do they have like a drawing thing in here? I thought they did. Paint. We're doing paint. Okay, this is like massive. I kind of like don't need all this space. Let me drop this down. Let me not do that. Alright, this is all I need really. So let's run through my. It's very close, but it's not there. So wait, actually, I do want this bottom page. I capped. Oh, controlling. Wait. I don't remember if I could probably just control V it, but you know. We ball. Peek. Alright, that's all I need. Now let's start drawing. Okay. Alright, so our added value is going to be 1. So we're basically going to like run through the stack. Nothing exists in the stack yet. So we're just going to pop in a new element with 0 in it. So here's going to be our stack. I'm going to put it down here. Stack's going to be like that. I'm not going to draw that actually. We know what it's going to look like. I'm going to say this is the 0th item. And then I'm going to put 0 here. Okay? It's just 0, 0 for now. Alright. Now I'm going to check the new one. So added value is 1. And the temperature of the current day is actually greater because it's now 74. So now it's 74, so it's greater. So I can actually put an additive value in it. So what I'm doing is I take my additive value, I'm adding it to the stack. Or I'm adding, so it's 1 plus 0, which is still 1, and then I'm going to update the stack with it. So this is now 1, and then I'm going to put that 1 into the answer. And I'm going to pop it off my stack. Okay, so I'm going to put this 1 here. And this gets popped off the stack. And now we have the next one, which is going to be at index 1. This is 74. And 0. So now I'm going to check 75. Actually, no, I'm going to just skip this part because this is all going to be the same. We know that, but like it's literally going to run the exact same. So I'm going to put a 1 here. Where things get interesting is once I get to 75. So now I have 75 at index 2 with value 0. Okay. I'm going to then take 71. I'm going to check it. So '71 is not greater, so I just put a 1 here pretty much. Yep, I just put a 1 there. Because it won't run through there, and then I just kind of insert it. So now I put 71. Wait, why am I putting a 1 there? Okay, 1 goes here. Okay, now I'm going to add in 69. 69 here. 4. So it runs through this. It's it is not greater than the previous temperatures. So it doesn't really do anything here besides just, so here it won't run, but down here it will run. The previous stack will be incremented by 1. Okay. And then now I have 72. 72 is bigger than these two, so we have 72. So what I'm going to do is I'm going to take 1 plus 0, and that's the new additive value. I'm going to insert it back in, so it's 1. Then I'm going to say that the answer at position 4, which means to be 5 because I did one indexing, is going to be 1. So I correct that. Okay, and then I'm going to pop that off the stack. I'm going to take this, I'm going to pop it off the stack. Okay, then I get to 71. And right now the additive value is still 1. Additive value is still 1. So I get to 71. Okay, I have an additive value of 1. This is 1, so I'm going to do 1 plus 1, so now it's 2. And then I'm going to insert it into my answer. And then I'm going to pop it off the stack. Okay. And then now I have 2. And 75 here has 1. So now I'm going to... I run into this where 72 is it's not greater than 75. So I'm going to basically I'm basically going to add the 2 here, so this becomes 3 now. And then 72 gets added here. And this is going to be 5, 0. Whoops. Brother. Whatever. That's close enough. Okay. Now I hit 76. Now 76 is bigger, so we're going to run it. I'm going to replace this with 1. Pop it off. Return it up here. So that's 1. Okay. And this will get popped. And then once more, 3 plus 1 will be 4. And then it will get popped. Okay, so what am I doing wrong? Even on my own like mental math, it still made 4, but my output is 3. Why? Okay, I need to, every single time I implement this, I need a print. I'm gonna basically do a print. I'm gonna say okay, I'm gonna put this here. That is 0. Hey man, you're gonna be okay. So here we have 73 being added to 1, and then it gets popped. 71. 74 is gonna be added to 1, and then that'll get popped. And then 75 is gonna be added to 1, because 71 wasn't strong enough to pop it. So. And then 69 was not strong enough to pop 71. So, gonna add 1 to that. And 71 is strong enough. Or, sorry, 72 is strong enough to pop 69, so I add 1. Oh, hold up. Here we go. Right here. Plus equals. Man. It's the annoying part about programming. Let's see if this is fast enough. If this is not fast enough, I have no idea. Mother. What? Oh, output limit. Yeah. It's not time on this output limit. Printed way too much items. Which makes sense. This should work. This is like very close to linear speed. No way. No way. How does that not compute? Oven, right here. This is like at the this is not even n. But I guess this could run up to. This runs up to n times. I mean, seriously, like, what is the time complexity of that? How are you supposed to make something that runs fast enough? I don't get it. It doesn't even have a requirement for time complexity. I don't know. I mean, I'm so confused on that. Just have to watch a video, I guess. That's upsetting. Dude, Max, relax. Alright, you should aim for a solution as good or better than O of n. What? Better than O of n? How the hell do you do that? I think consider reverse course, for example. What? Is that not pretty much what I did?
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve a problem, daily temperatures. We are just given an array of integers which represent temperatures, and we want to return an array answer such that at every single position in answer, it's going to be the same exact size as our temperatures array, and at every single position in answer, we want to know for the ith day, whatever the temperature was on the ith day, we want to find how many days did it take for us to find a temperature that was greater than the temperature on the ith day. So for example, let's take a look at this temperatures array. We can see there's 8 values in the temperatures array, and there's 8 values.
Sorry. While the stack is not empty and current value is oh my god. Dude, that's so much smarter. This is the current index minus the God damn it. I didn't even think about that. The current index minus the previous index, which I'm storing the previous index, that is the value. I don't even need this additive stuff. Forget it. Current index minus the last value. And I don't even need this no more because this is using additive values. Oops, wrong. What did I do wrong? Oh, my output's 4. Oh, duh. There's no shot that this is too slow. My lord! Gosh. That last test case is really trying me, man. Alright, so like my solution was very close to how it was supposed to be. Very close, but just those extra if statements were like cooking me. Eventually I'm going to have to start doing some DP. All right, daily temperature. All right, I'm gonna take a break from the stack stuff because it's killing me right now, man. It's killing me. I'm gonna move on to the next layer. Let's do one easy. I'm time constraint wise. Like I want to be done by like 6:15, so it gives me like 25 minutes. So I want to see how many easies I can get done in 25 minutes. Best time to buy and sell stock. Okay, this is like the sliding window problem, and I don't remember how to sliding window. I don't remember how to sliding window at all. Because I've only done it once in my entire life. I never really learned it algorithmically. I just kind of like brute forced, I think, this problem like probably a year and a half ago. Okay, so I'm given an array of prices where the prices at a current index is the price of a given stock on the ith day. I want to maximize the profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So if I buy it at 1 and I sell it at 6, it gives me 5. So if I remember correctly, sliding door is kind of like a greedy approach. Sort of. So I'm going to basically, I'm going to look for the smallest element, and then I'm going to look for the like kind of like the largest element. No, wait, no, hold on. Because like, what if I have? I'm sorry, I'm thinking like, what if I have like 1, 6, 1, sorry, 1, 6, 0, 7. Man, okay, how do I, how do I do this properly? Probably should not just jump right into coding. That's not what you're supposed to do, but hey, you know what we do? We don't listen. We don't listen. I'm going to say current max is going to be equal to 0 because 0 is the smallest price. Thank the Lord, no negatives. We're out the red today. Damn. How do you sliding window properly? Ah! It's upsetting me because I can't remember how to do this properly. So, like, my thought is you have basically, like, the minimum, and then, like, oh, once you hit another minimum, you kind of, like, swap it. But, like, that's so not the case. Because, like, if you have, like, 2, and then you go up to... Wait, no, that is the case. Dude, relax. 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 Jesus. Alright, my cat is like... He does not like when I'm recording videos at all. Alright, no, it should be good. I'm gonna say pointer. I'm gonna say left pointer equals 0, right pointer equals 0, and then I'm basically going to say that while right pointer is less than the length of prices, so I'm basically going to then do let's say current max, and then I'm gonna do a current. I'm gonna do a current min. I'm gonna say that this is equal to prices of 0. Buddy, relax, ease it, man. Holy. So it's probably like horrible naming conventions because current max and current min are not the same thing. Current max is like my answer. So I'm gonna say if dude, you have to calm down. If prices of right pointer minus prices of left pointer are well, I'm gonna name this called difference, so I don't have to just keep typing that up over. Difference is greater than current max, then current max equals difference. If wait, I don't even need this current min. If prices of right pointer is less than prices of left pointer, then I'm going to move it along. So I'm going to say left pointer. Oh my goodness, holy crap. Left pointer equals right pointer. And then I'm going to say right pointer plus equals 1. And then I'm going to return current max. Okay, so what this algorithm is doing is I'm basically having a 2-pointer approach. The left pointer should basically kind of be like on the smallest value that that we can make money off of. And then the right pointer should be on the largest value. So the price difference, it could be that like right here you have like 1, and here you have 100, and here you have 0. So the 0 is technically smaller than the 1. So it could be that the solution does not include the smallest value as the entry point. So that's why we want to hold a current maximum, so that we don't make that mistake. But like after we pass the 100, we want to drop down to the 0, and we want to see if there's anything bigger after that. You know, if there's a 100 again, then yeah, that's bigger, because 0 to 100 is much bigger than 1 to 100. Not much bigger, just only bigger by 1. But let's just run the solution and stop yapping and see if we're messing anything up. Okay, it says it accepts it. Let's fully send it. Nice. Okay. So that one is done. If I can remember that, these might get pretty hard, pretty challenging, I can imagine. A binary search. Binary search. This actually was one of my favorite algorithms, if I remember how to do it properly, but this is one of my favorites. I like this a lot. make a function called binary search. Actually, I don't even need to do that. I could probably use this regular search function. I'm going to say middle is equal to nums, length of nums divided by 2, integer style. Okay. I don't know if I have to plus a 1 on that. Let's see. If I have 3 digits, length it will be 3 divided by 2, and it'll round down because it rounds to the zeroth. So it would be 1.5 divided by 2 would be 1, which would be right in the middle. So yeah, no, that works. Then I'm basically going to say, hey, if nums of middle is equal to target, then return middle. That's it. Else, if nums of middle is greater than target, then I'm going to return nums, let's see, up into middle. I don't really need this other elif. This should automatically be like an else, but I like it for like understanding what I'm looking at. Okay, so nums middle, then it should be on the right side. I'm gonna do one more check. This is my base case. If the length of nums is equal to 1, meaning it's really just one item left, and sorry, I got itchy nose. And nums of... Oh, wait, no, this is not returned properly. What am I doing? I'm trolling. Holy. Because I'm recursively doing this. It's just like... it's not going to properly save the index. What's up, big guy? Wait, hold up. This is dumb. No shot. Oh, wait. Runtime error. Oh. Whoops. What am I doing? Oh my days. This is a pretty stupid way of solving this. I have a strong feeling this is probably not going to work, but I'll be pleasantly surprised if this does. Whoa! Sorry, my nose is itchy. If it's on the left side, I don't need to add it, I don't think. If it's on the right side, I do. Unhashable type list. Well, I'm confused. What am I trying to hash? Hello? What am I trying to hash? Alright, I'm trolling. Alright, ignore that. I should not be using recursion on this problem. Alright, instead I'm just gonna do what is my base case of this situation? I mean, I'm gonna run O of n log n times for sure, but like, do I really need to count that? It's kind of a lot of calculation, just find O of log n, you know? Like, what's the point? Let's see. So let's start on the 6 divided by 3, divided by 2, which is 3, which is here. Okay, 5 is less than 9, so then I have 9 and 12. Then this will be 2 divided by 1, which gives me 12. Yeah, that makes sense. Ugh. I've done binary search all the time, but I'm choking right now. I'm trying to think of like what my edge case is. What is the what is the edge case for this situation? Okay, so this edge case shouldn't run. I'm like actually. Oh, because I'm doing plus middle. Bruh. I mean, it's not even running properly anyway, so that shouldn't matter. But so, 5 is less, then we do 9, 12. So we have 2 divided by 2, which is 1, so then we just check 12. That's it, like that. Okay, so I'm gonna do check middle minus 1, so 6 divided by 2, 3 minus 1, 2. This is 3, which is less than 9. Therefore, we're gonna check the right half. Okay, we have 3 divided by 2, 1.5. Print integer of 1.5. Yeah, and then if I do 0, then oh, I do it only if it's odd. If length of nums mod 2 equals 0, which means it's even, then I'm gonna say that happens. Else, I'm gonna say this happens without the minus 1. Is that right? Is that what I'm missing? I'm gonna say middle equals 0 to start that off. I don't think it's gonna like make the actual thing work, but now it should be more acute. Okay, cool. Wah. Alright, so that's how I properly get the middle, thankfully. So 6 divided by 2 minus 1, so we're going to check 3. Okay, 3 is less. Then we have 3 divided by 2, which is just going to be 1. Okay, so then we check 9, and 9 is the target. Then we just return 9. This is really horribly done. I'm like totally dropping the ball on some binary search right now. This is not going to succeed. List index is out of range. Okay, what part of this is out of range? We have 2. If it's even, then you do 2 divided by 2 minus 1. Do 0. I'm sorry. What here is actually out of range? This is chopped. So chopped. Should be good. Somehow my middle is -1? Yo, how the How did that happen? Okay, my middle is 0. I'm basically saying is 2 is greater than the target, so then I'm gonna basically go from okay. This is like ridiculously poorly done. My days. Nah, man, that was horrible. That was horrible. How do you, like, properly, cleanly write that? Let's pull it up. Let's pull it up because that was not good. I want to... Oh, wow, he has a beautiful, beautiful... I was confused. Like, what? Is this also beautiful? From Microsoft. Recursive binary search. Alright. Let me look how he wrote that. He has left, right. Okay, so he's doing the left-right approach. So if left is greater than right, then here. Okay. Yeah, that makes sense. Okay. Alright. That, it is past 6:15. So, I am gonna call it here. Apologies for the hiccups, but you know, that's how things go. not everything is clean. Thank you for watching, and I will see you tomorrow.